There is a structure made of mud, clay, and ash that kept ice frozen in the middle of a desert where daytime temperatures reached 104 degrees Fahrenheit. It cost almost nothing to build. It used no electricity. It required no moving parts, no refrigerant, no compressor, and no monthly bill. The Persian Empire built these at scale starting around 400 BC. Entire cities had access to ice, cold drinks, and frozen desserts. 2,000 years before the first commercial refrigerator was ever sold. The mortar they used, a mixture of clay, sand, lime, goat hair, egg whites, and ash, tested equivalent in insulation to 400 millimeters of modern polystyrene foam. That is 16 inches of synthetic insulation replicated by mud. Max Fordham, LLP, a UK engineering consultancy working with University College London, ran computational models on these structures. The thermal performance matched a modern wall built with 100 millimeters of concrete and 400 millimeters of polystyrene, a U value of 0.1. The global commercial refrigeration industry generates over $51 billion a year. The average American refrigerator costs between $138 and $350 a year to run, every year, for as long as you own it. You have probably never heard of the Yakhchāl. That is not an accident. The answer starts about 2,400 years ago on the arid plateau of central Persia, in what is now modern Iran. The people who lived there faced an engineering problem that sounds impossible. Summer temperatures above 100 degrees, annual rainfall under 5 inches, and yet they wanted ice, not as a luxury, as a necessity, for food preservation, for medicine, for daily survival in a landscape that would kill you if your food spoiled 2 days too soon. So they built the Yakhchāl. The word itself means ice pit. Yak, ice. Chal, pit. And the name tells you everything about the engineering philosophy. You do not fight the heat, you go underneath it. A typical Yakhchāl rose 60 feet above ground, shaped like a massive beehive made of mud brick. Below it sat a deep underground chamber, sometimes holding 6,500 cubic yards of storage. The walls at the base were over 6 feet thick, built from a mortar called saruj, a mixture of sand, clay, lime, ash, goat hair, and egg whites, needed for 3 days until it became completely waterproof and nearly impervious to heat transfer. The recipe for saruj was not written down in any single text. It was a trade secret passed between builder families for generations. Clay and limestone mixed in a 6:4 ratio, needed for 3 days straight. Furnace ash folded in for its silicate content, which enhanced insulation. Goat hair added for tensile strength, preventing cracks that would let warm air seep through. Egg whites as a binding agent that made the entire mixture nearly waterproof. When applied 6 feet thick at the base, these walls became thermal fortresses that modern material scientists still study. But here's the part that makes engineers stop and pay attention. They did not just store ice, they made it. In a desert, at temperatures above freezing. Outside, every Yakhchāl sat a series of shallow pools called pouliks. Tall shade walls, some reaching 40 feet high, blocked the sun from the south and west. At night, workers flooded these pools with water from underground aqueducts called qanats, and then physics took over. On a clear desert night with almost no humidity in the air, the surface of that shallow water radiates heat directly into the sky. Not into the air around it, into space. The atmosphere has a transparency window between 8 and 13 micrometers where thermal radiation passes straight through, hitting a heat sink at roughly 3 degrees above absolute zero. The water surface drops below freezing even when the air above it has not. To your eye, it is a puddle in the sand. At the molecular level, it is a radiator beaming heat into the vacuum of space. To the water, the clear night sky is not air. It is a freezer door that never closes. Meaning, the Persians figured out that you do not need cold air to make ice. You need a clear sky, dry air, and a shallow pool. The physics do the rest. And here is the part that matters most. This mechanism is not biological. It is not chemical in the way that a refrigerant is chemical. It is pure thermodynamics. Radiative cooling cannot be outperformed by a warmer atmosphere. It cannot break down. It cannot leak. It does not care about your electric bill. The physics do not negotiate. That is next. So if a 2,400-year-old mud structure can make and store ice in a desert with no electricity, why does the average American household spend between $138 and $350 a year running a refrigerator? The commercial refrigeration equipment industry alone was valued at over $51 billion in 2025. Add in industrial refrigeration at another $24 billion, and domestic refrigerator sales. And you are looking at a combined market well over $100 billion a year, globally. A fridge lasts about 12 to 15 years before it needs replacing. A new full-size refrigerator costs between $800 and $3,000. Over a 30-year span, in a typical household, you will buy 2 or 3 of them. Call it $3,000 in hardware alone. Add electricity at roughly $200 a year average, and that is another $6,000. $9,000 over 30 years minimum to keep your food cold. A root cellar, built on the same thermal mass principles the Persians used, can cost as little as $250 in materials if you use earth bags. It lasts decades. It uses zero electricity. It maintains temperatures between 32 and 40 degrees Fahrenheit year-round in most temperate climates. So why does every new American home come with a refrigerator hookup, but not a single one comes with a root cellar? Why did the average home in 1920 have a root cellar and the average home in 2025 does not? Why does a $100 billion industry exist to solve a problem that dirt and shade solved 2,400 years ago? Why does no home builder in America offer underground cold storage as a standard feature when every home builder in Persia did it for free? Why is there no section in any modern building code that addresses passive cold storage? You already know the answer. It is not because the technology does not work. It is because a system built from dirt, lime, and ash that lasts 80 years and costs nothing to operate is a terrible business model. That is not a coincidence. Stay with me. Here is where it gets practical. Here is exactly what you need to build a modern Yakhchāl-inspired cold storage system for under $40. This is the simplified backyard version, not the 60-foot dome. Same physics, scaled for a homestead, shopping list. 155-gallon steel or plastic drum. Used ones run $10 to $15 on Facebook Marketplace or at Tractor Supply. New from Uline or Home Depot, $25 to $30. 1 roll of basic fiberglass insulation or rigid foam board. Owens Corning R13 roll at Home Depot, around $22. You will only use part of it. Leftover from another project works fine. 1 4-inch PVC pipe, roughly 6 feet for ventilation, about $8 at Lowe's or Home Depot. Straw bales for top insulation, $3 to $5 each at Tractor Supply or your local feed store. You need 2. Gravel for drainage, 1 bag at about $4 from any hardware store. A sheet of exterior plywood or a heavy wooden lid. Scrapworks, $5 or free. Total cost, scavenging smart, $15 to $20. Buying everything new, $30 to $40. Step 1. Choose your location, north side of your property if possible. Under tree shade is ideal. You want the spot that gets the least direct sunlight during summer. Dig a hole 4 feet deep and about 3 feet across, wider than the barrel by about 12 inches on each side. Step 2. Pour 3 to 4 inches of gravel into the bottom of the hole. This is your drainage layer. Without it, groundwater seeps in and you lose temperature control. Tamp it level. Step 3. Lower the barrel into the hole. You want the top rim sitting about 6 inches above ground level. If it sits flush, rainwater floods in. If it is too high, you lose earth insulation. Step 4. Pack the gap between the barrel and the dirt walls with your insulation material. Rigid foam board cut into strips works best. Fiberglass batting works if you wrap it in plastic sheeting first to keep moisture out. Fill the gap evenly all the way around. Step 5. Cut 2 holes in your lid, 1 on each side. Insert 4-inch PVC pipe sections, about 18 inches long, angled slightly outward. 1 pipe should extend down near the bottom of the barrel. That is your cool air intake. The other stays near the top. That is your warm air exhaust. This creates a natural convection loop. Cool air sinks in, warm air rises out. You will know the ventilation is working when you feel a faint draft at the top pipe on a cool evening. Step 6. Fill the barrel with your produce. Root vegetables on the bottom. Apples and pears higher up, separated by layers of straw or newspaper. Never store apples directly next to potatoes. Apples release ethylene gas that causes potatoes to sprout. Keep them in separate containers or separated by at least 1 straw layer. Step 7. Cover the top with your plywood lid, then pile on 2 straw bales broken apart and spread evenly. In winter, add an extra layer. In summer, wet the straw lightly in the evening. This adds evaporative cooling on top of the earth insulation, exactly the way the original Yakhchāl shade walls worked. For a more advanced version, do what the Persians did. Build a shade wall on the south side. Even a 4-foot tall piece of plywood or a stack of straw bales blocking direct sun from hitting the barrel lid will drop the internal temperature by 5 to 8 degrees. For extreme cold climates below 0, add a removable plug for the intake pipe so you can seal it during deep freezes. This prevents your produce from freezing solid. And here is the part that surprises most people. The same barrel setup works for 3 other things you probably never considered. First, meat curing. If you are dry curing bacon or making jerky, you need consistent temperatures between 36 and 40 degrees with moderate humidity. A buried barrel with a small dish of water inside holds those conditions naturally from October through March in most of the northern United States. Second, cheese aging. Hard cheeses like cheddar and Gouda need 50 to 55 degrees and 85% humidity for weeks or months. Your barrel, without the extra straw insulation on top, sits right in that range during spring and fall. Line the inside with a damp cloth for humidity control. Third, seed storage. If you save seeds from your garden, they last 2 to 5 times longer when stored cold and dry. Seal them in mason jars with a silica gel packet and drop them in the barrel. Consistent 40-degree storage extends seed viability from 2 years to 5 or more. One setup. 4 uses, under $40. Here is the part that ruins 90% of builds. People skip the ventilation. They seal the barrel completely because they think trapped cold air equals better storage. Wrong. Without airflow, ethylene gas builds up, humidity goes uncontrolled, and everything rots within 3 weeks. 2 pipes, 2 holes. That is the difference between a cold storage system and an expensive compost bin. Total cost per use, assuming 3 years of service from the barrel, under $14 a year. Compare that to $200 a year running a second fridge for your garden harvest. Real-world performance. Agricultural researchers have confirmed that properly designed underground storage maintains temperatures between 32 and 40 degrees Fahrenheit with 90 to 95% humidity, matching the ideal conditions for root vegetables. Potatoes stored this way can last 4 to 6 months. Carrots wrapped in damp sand inside these systems routinely keep 3 to 4 months. Apples stored in layered straw, 2 to 3 months. Fred Matlack of Veracruz, Pennsylvania, built a basement root cellar using these same ventilation principles and documented consistent near-freezing temperatures through the entire winter. The earthbag root cellar method, documented by Stuart and Shannon Stonger in The Doable Off-Grid Homestead, uses 600 polypropylene sandbags at under 20 cents each barbed wire and rebar to build a walk-in version for roughly $250 to $400 total. Soil temperature at 4 feet deep stabilizes at between 50 and 55 degrees in most temperate climates, year-round. That is your baseline. Add proper insulation and ventilation, and you bring that down into the high 30s. Because this channel always gives you the full picture, here is where this system does not work well. In USDA zones 8 and above, the Deep South, Gulf Coast, Southern California, most of Texas, ground temperature at 4 feet may only reach 65 to 70 degrees. That is better than surface temperature, but not cold enough for true long-term storage. In those climates, you need to add evaporative cooling, a buried fridge with a damp sand layer around it, or combine it with a CoolBot controller and a window AC unit. This method works best in zones 3 through 7, where the ground naturally cooperates. Safety note. If you are burying a used refrigerator or freezer as your container, have a certified technician remove the refrigerant first. Freon leaking into soil is not a homesteading move. It is an environmental violation. Use a barrel instead. Simpler, cheaper, no hazardous materials. Same physics. This is the same common sense precaution you would take with any recycled appliance. Here is the part that stays with me. 2,400 years ago, a Persian engineer in the province of Yazd, with no thermodynamic textbook, no computer simulation, no electricity, no supply chain, figured out that you could freeze water in a desert by letting it stare at the sky. He taught his apprentice. His apprentice taught the next generation. For hundreds of years, entire cities ate cold food, drank chilled sherbets, and preserved medicine through killing summers, because the knowledge kept moving. And then, sometime in the 20th century, in the rush to connect every home to an electric grid and every kitchen to a compressor, the knowledge stopped. Not because it failed, not because something better replaced it, but because a system that costs $40 and runs on physics does not generate a monthly bill, and an industry that generates $100 billion a year cannot survive on customers who do not need it. Now you have it back. You know that dirt at 4 feet holds 50 degrees. You know that a barrel, some insulation, and 2 PVC pipes can store your harvest for months. You know that the Persians made ice in a desert 2,000 years before anyone invented a refrigerant. You also know what $100 billion depends on you not knowing. If there is someone in your life who has been throwing away half their garden harvest every September because they ran out of fridge space, send them this video. They deserve to know. Knowledge like this does not disappear on its own. It gets buried. This channel digs it back up. Thanks for watching. I will see you in the next one.